Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In this video, I will be demonstrating how to use the built-in high-speed counter for the Maple Modular and Maple Micro PLCs. In this video, I'm going to be using a PLC ES0808P Maple Modular, but you can use any Maple Modular or Micro PLC. Here is a wiring diagram for a high-speed counter using a Maple Modular PLC. And in this example, I'm sending an input signal from a signal generator going into X01, and that will initiate a pulse and a down count. And to initiate an up count, I will be sending 24 volts into X00. Keep in mind that this setup can also be used for the Maple Micro PLCs as well. This diagram can also be found on the How to Program a High-Speed Counter tutorial page on the Maple Systems website. The Maple PLCs for both the Maple Modular and Maple Micro have two built-in high-speed channels and allow up to a counting speed of 20 kilohertz. For high-speed counter, there are two phases to choose from. So as you can see in this window, you can choose one phase or you can choose two phase. One phase means you're counting in one direction, either counting up or counting down. Two phase counts in both directions. Okay, first to bring up this high-speed counter, this configuration screen, you will need to go to Program, right-click on Program, select New Program. First, in order to download to the PLC, in order to go online, you will need to create a regular scan program, which is right here. I have that configured here. And then you will want to choose Special Configuration, HSC. This can also be used for the Maple Micro. So it can be used for Maple Modular or Maple Micro, and then once you select this, you'll hit OK, and it'll open up this screen. Now, once the screen opens, the first thing you want to configure is your starting address. Now, for high-speed counter, store your data in either D, M, L, or K registers. I have D selected here, and I just have it starting at 100. You can have it start at 0 or 200 or 500, whatever one you want to, and it's going to go all the way to D117. And another thing I want to show you is that you can have two channels. So the built-in high-speed counter is two channels. So for this, I'm just going to configure one channel, but of course you can do two. So for count mode, you can choose between a linear counter or a ring counter. A linear counter has a range from negative 2.1 billion, and then it goes up to positive 2 billion. That's the minimum to the maximum for your linear count. So when the count value reaches the maximum value, a carry is occurring, and when the count value reaches at the minimum value, borrow is occurred. So if carrying occurs, the counting stops and no more up count is performed, but then you can also count down all the way down to the minimum value. And then if borrow occurs, minimum value, counting stops and no more down count is performed, but it can count back up to the maximum value. If you were to choose a ring counter, this is a user-defined minimum value or maximum value, so you typically would use this if you are using RPM. So let's say you want to be in a range from 55,000 RPMs to, let's say, 70,000 RPMs. So your minimum is 55 and your maximum is 75. So when performing the ring count, for the up count, when the count value exceeds the user-defined maximum value, 70,000 in this case, carry occurs, but the counting is executed continuously, and it will also reset the count. So you would define that here in your max and your minimum. And you can also set up an internal preset and external preset. So you can, let's say, have a preset value. If it's between 55 and 7, you can have it at 60. So it would start at 60,000 and then go up to 75,000 RPMs. When it hits 75,000 RPMs, it will carry and then go back to the minimum value, whatever that is set at. And the compare output, if you decide to use the first 5 here, whether it's current count, less than compare value, less than or equal to, and so on, the first 5 here, you do not need to fill anything for the max compare value because you are not using it. So you would just put your minimum compare. Let's say you want it to be 20. If you have your compare mode set to greater than the compare value, so this option here, if it goes over 20, it will turn on. So that's where you would want to use this for if it goes over the count here. If you use this one here, excluded, you'll want to set the minimum compare value to 0, because if you don't, the compare output will turn on. Set this to 0, and then you'll compare it with the maximum value. So let's set this to 20 instead. In this case, if it goes over 20, it will turn on the compare output. So this is a case of using the max compare value, and I will show this later on. And then of course, unit time, the default is 1000 milliseconds, which is also 1 second. Typically this is what you would set this at. If you're using pulses per second, you want to have this set to 1 second. And then pulse per 1 cycle, this is 1. I'm going to leave this as it is. And then if you're using RPM, you would set this to 1. And then you can set your pulse per 1 cycle. Maybe you want to have it set to 50. So maybe when it hits 50 pulses, it will be 1 RPM. You would set that however you would like. In this case, I'm going to be using pulses per second. So I'm just going to have this set to 1 and then 1000 milliseconds here. Up here in your current count, this is going to be your current count window when we go online. And then of course your pulses will be here. I'll bring up the help file. And to find all these major functions for your built-in high-speed counter, you'll go to your contents and then CPU PLC ES or PLC FB, and then scroll down for PLC ES high-speed counter. And then drop that down, and then you can look at your major functions. So counter input, counter types, compared output. All the major functions you need to know about your built-in high-speed counter are going to be in your help file, and it will be in this section here. And if you need more than 2 channels, you can use an expansion module, but that's only for the Maple Modular. You can add 2 more channels by adding one high-speed counter IO module, and that is the IO SHSC02. This can be used for any Maple Modular PLC, but not for the Maple Micro PLC. And then the last thing you'll want to do in your configuration here, and you'll need to do this in order for your high-speed counter to work, you will need to check off Enable Count. And if you have 2 channels configured, which I don't here, but if you have 2 channels configured, you'll need to make sure that your channel 2 is also enabled here. Now let's go online, go to online, and then go to link plus download plus monitor. Okay, now we are online, and to monitor your high-speed counter, you'll need to click monitor. And as you can see down here, your status flags, our enable count is initiated. And now when I send a signal, when I send the pulse signal to X01, you will see this turn on down count, and then the current count will count down. And then when I apply 24 volts into X00, you will see the count up. I want to show an example of using the compare mode, just like I mentioned earlier. So the first example I'm going to show if the current count is greater than the compare value. So like I mentioned before, if you're using the first 5, it's going to compare to the minimum value. So first we're going to enable compare output, and I'm going to use Y10 to show the compare output. When it goes over the compared value, the minimum compare value, it will turn on Y10. I'm going to set my minimum value to 20, this example. You can set it to however you like. And then to make changes here, I need to go to online modify. And now you can see that the enable compare output is turned on and the status flags. And so now if I start my high speed counter, so I'm going to send 24 volts, and I'm going to start sending a pulse, and you can see it counting. Current count is greater than compare value, and it hits 20. It's going to turn on that compare output. As you can see from the camera feed, it has turned on Y10, so that can act as an alarm. So if it goes over a certain value, it will turn on Y10, and it will signal it has gone over that compared value. And so I'm going to stop the count, and I'm going to show you another example of using the max compare value. So I'm going to set the minimum to 0, and I'm going to use current is less than or equal to compare 1, and then current is equal or greater than compare 2. So this is going to be using the max value. as the compare value. And I'm going to put the max value at the same thing. We're just going to put it at 20, change this to 0, use the same compare output. I'm going to hit online modify. And I'm going to send 24 volts to do an up count, and then send my pulse signal. So now you can use the max compare value if you like, and when it hits 20, it will turn on that compare output, and it did. Now I'm going to show an example using the minimum and max compare value to demonstrate if the current count is below the minimum value, an alarm will go off, which is being represented by the compare output Y10. And if the current count goes over the maximum value, it will also set up an alarm, which is also Y10. I'm also going to be using the same count mode, linear counter, and the same compare mode that we used early on. So I'm going to set my max compare value a little higher this time. I'll set that to 50, and minimum value I'll set to 20. And you can see my camera feed, and I'm going to press monitor. And as you can see, the compare output is on because we are actually below the minimum value, which is at 16 right now. And I'm going to send 24 volts, and then I'm going to send a pulse. So now it's between that range. I'm just going to stop, and as you can see, it's been within that range of 20 and 50. So an alarm has not gone off because it's in that range. So now I'm going to send a pulse, and when it goes over 50, it'll turn on Y10. And I'm going to stop setting 24 volts, so it'll be a down count. So it's counting down now. I'm going to increase the pulse a little quicker. And then once it gets below 20, it'll set that alarm off again. So this is an example of using a particular range between 20 and 50. So when the count is within that range, so when it goes out of the range, if it goes beyond 50, an alarm will go off. If it goes below 20, an alarm will also go off as well, and that's being represented by the compare output, which is Y10. Okay, lastly, I'm going to demonstrate using a ring counter, and I'll be using the ring counter max. I'll also be using the max compare value and the minimum compare value. So I'm going to change the count mode to ring counter 0 max. I'll have my ring counter max set to 50, max compare value to 40, and minimum compare value to 0, and I'm still going to be using my compare output at Y10. So if the count goes beyond 40, the compare output will turn on, and then once the count hits 50, it will reset to 0 and turn off the compare output. So here's my camera feed again. I'm just going to do online modify, monitor. So now we have these settings, and you can see that our enable compare output flag, so we are using that. This is all checked off, looks okay. I'm going to send 24 volts, and then I'm going to start setting my pulse. You can see the count going up. So once it gets to 40, it will turn on that compare output. When it hits 50, it will reset to 0 and turn off the compare output. So that's what we wanted. So this is demonstrating using a ring counter with that same compare mode we use in the linear counter, and then also using the ring counter max to reset to 0, and also the max compare value. If it goes over that value, it will turn on the compare output, and when it hits the counter max, it'll reset to 0 and turn off the compare output. This is all I'll be covering today on high-speed counter for the Maple PLCs. To get more information, please visit the How to Program a High-Speed Counter tutorial page on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.